Hi there guys, welcome back to another video. In today's video, we'll see the question of running sum of 1D array, right? So what does a running sum means? So as the question is, given an array, we define a running sum of an array as running sum I is equals to sum of from nums of 0th index to nums of ith index, and we have to return the running sum of the whole nums array, right? So you're given an array, you need to traverse this from left to right, and then uh, the output array or the output vector for ith index would be the sum of previous elements, right? So uh, for example, um, let's suppose 1, right? So there is no previous element to 1, so 1 would be copied as it is. Then you have 2, right? So a previous element to 2 is 1, right? So this element plus all the previous elements, right? So 2 plus 1 is 3, so 3 is added, right? Then we have yeah, then we have 3, right? So this element 3 along with all the previous elements, right? So 3 plus 2 plus 1, so 3 plus 2 is 5, 5 plus 1 is 6, so 6 here, right? Then then 4, right? Accordingly we have 4 also, right? So 4. So running sum for this element would be this element, that is 4, plus sum of all the previous elements. So 1 plus 2 plus 3 plus 4, that will give us 10, right? So that will give us 10. So yeah, let us code this one. So int so what we'll do is that let us first actually see how we are going to implement this, right? So we have got an array, right? And we have all the different elements 1 3 6 and 10, right? And now what we need to do is that we will declare a variable, right? And we'll store, and this variable will call it as sum, right? And it will have an initial value of 0. What we'll do is that we'll traverse the array from left to right, right? And for each time we iterate, we'll take the element, this element, and we'll add it into this, right? So 0 plus 1, 0 plus 1 would be 1, right? And then we'll create another new array, right? And we'll push this into this, so 1 goes here, right? The next element is 3, so 1 plus 3, 1 plus 3 is 4, so 4 is pushed here, right? And then you have 6, so 6 and then you have 6, right? So 4 plus 6, right? So 10 is pushed here, right? And then you have so we had 10, right? And so 10 10 plus 10, 10 plus 10, right? So 20 is pushed here, right? So this is how we will calculate. We just need an extra variable and an extra array or a vector. This can be done without the extra array in constant space, uh, but we will not attempt that, right? So the first we'll declare int sum equals to 0, the sum variable. Then we'll create a new vector of type int with the name result, right? And we'll iterate the array. So for int I equals to 0, I is less than nums dot size. I plus plus, right? So nums dot size so nums dot size is a dot size is a function that gives the length of the vector or array, right? So for example, if an array is of 6 elements, it will give out 6. If an array is of 7 elements, it will give out 7, but it will not be 0 indexed, it will be indexed from 1, right? It will be indexed from 1, right? So yeah, but it will be dynamic. So sum is equals to sum plus nums of I, and then what we need to do is that the result dot push underscore back of sum. Right. So what we are doing is that basically uh, we are saying that, hey, this is a sum variable. What you do is that traverse the whole array and one by one uh, add the ith index of add the value at the ith index of nums to the sum, and then push it one by one to the result vector, right? And then we print out and we'll return result, because this is a vector function, so we'll have to return a vector only for this, right? And yeah, so now we'll run this. Yeah, all the test cases have passed. Here once again, let's see the logic. So first element, the running sum for the first element would be the same. The second element, so summation of this element, that is 1, plus the elements before it, that is 1 plus 3, right? That is 4. 4 is printed down here. Then we come to the third element. So sum of third element, that is sec2, plus sum of all the elements before it, so that is 2 plus 1 plus 3, that is 6. So we log out 6, and same goes on till the end. We'll submit this. Yeah, and you see that our solution beats 68.7% of all solutions when compared to the time complexity, and 54% when compared to the space complexity. We could also reduce the space complexity by not by replacing those values at the same index, but that is another topic for another video. So yeah, thanks for watching.